Now consider the element sigma I alpha. Sigma I alpha, where I ranges from 1 to n. Sigma I alpha, where I ranges from 1 to n, which is called the k conjugate of alpha, which is known as k conjugate. K conjugate of alpha. The k conjugate of alpha is defined as sigma I alpha. K conjugate of alpha is defined as sigma I alpha. So sigma I alpha, where I ranges from where to where? I ranges from 1 to n. So this is an important result. The theorem states that the field polynomial, what is the field polynomial? It is defined as f alpha t equals product I ranges from 1 to n t minus sigma I of alpha. So what is sigma I of alpha? That is the k conjugate of alpha. So the result says that this field polynomial is nothing but power of the minimal polynomial. It can be expressed as power of the minimal polynomial f alpha. Minimal polynomial p alpha, not f alpha, p alpha. What is p alpha? P alpha be the minimal polynomial of theta over q. How to prove this one? What is p alpha? That is the minimal polynomial. Then let q equals p alpha. So that means q alpha, that means q be the minimal polynomial, f alpha be the minimal polynomial. So q equals p alpha. So q alpha be the minimal polynomial. Then we know that this p alpha be the minimal polynomial, q equals p alpha. Clearly this q be the minimal polynomial. Now since q be the minimal polynomial, then it is irreducible. Q is irreducible. Okay, q is irreducible. What is alpha? Let alpha be the zero of the field polynomial. Zero of the field polynomial. What is field polynomial? F alpha. Means sigma I alpha. Sigma I alpha are the zeros of this f alpha of t, or f alpha as s of f alpha of t. Let q equals p alpha. P alpha be the minimal polynomial. So q be the minimal polynomial of p alpha, which is irreducible. Let alpha is zeros of the field polynomial p alpha. Therefore, since by the irreducibility from the factorizing of f into, you can factorize this f. What is f? F equals f alpha. Okay, f equals f alpha. So by the factorizing of f into irreducible, we know that this f equals some q power s into h. Okay, yes. What is q? Q be the minimal polynomial of p alpha. Q equals p alpha. That is the minimal polynomial. This q is irreducible. And let alpha is zero of the field polynomial f, or simply f alpha, whatever may be. So this f is nothing but from the factorizing of f into irreducible, f equals q power s into h. Now our claim, we have to show that this f equals q power s. Q means p alpha or p alpha power s. That is the field polynomial is power of the minimal polynomial. That is our requirement. So in order to prove f equals q power s into h, then we have to show that this h is a constant polynomial, or h is a constant, simply, not constant, simply h is constant. Here we got f equals q power s into h, where q is nothing but p alpha. What is p alpha? It is given p alpha be the minimal polynomial. Now to show f equals q power s, here h we have to show that this h is constant. How to obtain this f is q power s into h? Because from factorizing f into irreducible. Okay. How to prove this h is constant? If h is not constant, what happens there? Suppose h is not constant, then some alpha I. What is alpha I? For some alpha I equals sigma I of alpha. Why? Because we know that sigma I of theta, the field isomorphism, sigma I from q theta to q theta I in such a way that sigma I of theta equals theta I. Okay. So what is alpha? Sigma I of alpha? Alpha I. So sigma alpha equals sigma I of alpha. We know that sigma I of alpha is r theta I. Why? Because we can choose this alpha from alpha falling where? Q of theta. That means alpha equals some r of theta, where r fallen where? R fallen q of t with the degree of less than the degree of the number of fields. Okay, this is our choice. So clearly, this h is alpha equals sigma I of alpha, that equals r theta I. So clearly this alpha I is a 0 of h. If h is a constant, then we choose letter alpha I means sigma I of alpha, or it is r theta I, be a 0 of h. Okay, here f equals q power s into h, where there is a restriction since f it is obtained from the factorizing into irreducible. Here q and h are co-primes, means GCD of q and h is 1. Q and h are co-primes. Okay, let alpha I be the 0 of h if possible, where alpha is r theta. If g of t, define a polynomial g of t. G of t equals h of r of t. Why? Because h is a non-constant polynomial. That's our choice or assumption. If g of t equals h of r of t, then what about g of theta I? G of theta I equals h of r theta I. What is r theta I? That is alpha I. Okay, but what is alpha I? Alpha I is a 0 of h. Since alpha I be a 0 of h, alpha is nothing but r theta I. So r theta I is a 0 of h. So for what is h of r theta I? H of r theta I equals 0. So g of theta I equals 0. That means g of theta I equals 0. But what is p? P be a minimal polynomial of theta. This p be a minimal polynomial of theta over q. That is p of t. What is p of t? It is t minus theta 1 etc. into t minus theta n. P be a minimal polynomial of theta. In particular, p of theta I. What is p of theta I? So it's a p of theta is also 0. So p of t or p be a minimal polynomial of theta over q. So clearly this p be a minimal polynomial of theta I. So g of theta p be a minimal polynomial of theta I, and g of theta I equals 0. So that means p must divide g. Okay, p must divide g, that is g of theta equals 0. Now what is h of alpha? What is alpha? R theta. So h of alpha equals h of r theta. Alpha equals r theta. What is h of r theta? H of r theta equals g of theta. Okay, h of r theta, h of r t equals g of t. So by this assumption, h of r theta equals g of theta. So what is alpha? Alpha is a 0 of h. But h of alpha equals h of r theta. Since g of theta I equals 0 for all I. So what is g of theta? g of theta is also 0. Why? Because theta 1 etc. theta n are the zeros of this polynomial. So h of alpha equals again 0. h of alpha equals 0 and P alpha be a minimal polynomial. So clearly here Q divides H. Why? H of alpha equals 0. And what is P alpha? P alpha be the minimal polynomial of P alpha be the minimal polynomial. So this P alpha divides H. What is P alpha? P alpha means Q. So Q divides H. This is a contradiction. Why? Because Q and H are coprimes. So this contradiction is due to our wrong assumption. Therefore H is constant. When H is constant, F equals Q power S. Why? F equals Q power S. What is Q power S? Q power S means yes, H is constant. Again, what is H is constant? So do you say that H equals 1 there? Okay, why? Because H is constant and H is a monic polynomial. According to the why? Because it is obtained from the factorization of irreducibility. So H is constant. Moreover, H is monic. Therefore, what about that H? H equals 1. When H equals 1, F equals Q power S. What is Q? P alpha. So what is F there? So that implies F equals P alpha power S. So this is the requirement, that is the field polynomial is nothing but the product of the minimal polynomials. Okay. Here this is the most important part of this theorem. That is when H is not a constant, alpha I be the zeros of H, then H of alpha I means H of r theta I, g of t is H of r t. H of r theta I equals 0 means g theta I equals 0, but P be the minimal polynomial for theta I, so P must divide G. Similarly, H alpha equals 0 and P alpha be the minimal polynomial of alpha theta, so clearly Q divide P alpha divides H, but P alpha means Q divides H. That's a contradiction to the choice of Q and H, means they are related coprimes. So H is a constant, but H is monic. Monic means H is a monic polynomial. So clearly H equals 1. Agreed. So F equals Q power S, that is P alpha power S, that is the field polynomial can be expressed as the product of minimal polynomials. Agreed.